All right. Well, hello everybody. My name is Stephen Holsapple. I'm here with Ethan Hall. We're from the LinkedIn Tools team. One of the things that we work on is the Gradle build system at LinkedIn, and that's what we're here to talk about a little bit. I should also introduce Zvezdan Petrovic. He's worked on a lot of what we're presenting today as well. So in particular, what we want to talk about is Python and Gradle. Last year, we came to Gradle Summit 2015. We're in Santa Clara, and we presented our ideas around building an idiomatic Python build system using Gradle. One of the key designs or decisions that we made was not to replace Python as a build system, but to rather enhance it. So we chose not to change anything that normal Python developers are used to: setup tools, pip, pex, virtualenv. We kept all of these ideas, and rather we enhanced them with Gradle. In doing so, we figured that we were making it easier to onboard. It was going to be easier for us to stay agile with the changing Python environment, among other things. One of our key philosophies was to let Python do what Python does well, and to let Gradle do what Gradle does well, and doing so not to tread on Python. When asked why would you want to do such a thing, why isn't setup tools good enough for you? There was two major reasons. First, dependency management is a hard problem. And I know I'm preaching to the choir at this venue, but when you go to a regular developer seminar, or engineering seminar, and you say dependency management, the first thing that probably comes to their minds is something like POM XML, or setup.py, or requirements.txt, package JSON. But we would argue that although declaration is fundamental part of dependency management, that there's a lot more to it than just declaration. We need to start thinking about things like how are we going to shepherd out our changes, and in what order are we going to do so? We need to be able to answer questions like, which of my applications in my production environment need a security patch that we released 10 minutes ago? We need to be able to reason about how we resolve conflicts or just resolve dependencies in general. And last, we need to figure out how it fundamentally changes how we build, test, and deploy our code. And so I think the status quo with build systems today, they don't really solve, they don't even touch on these problems. And so we really needed to figure out at LinkedIn scale how to solve this problem. Second, building projects composed of multiple languages in and of itself is not a hard problem, but the solutions tend to be very messy. In 2 slides, I'll talk a little bit more about that. I'll give us a real-world example. So I'm going to punt on that for now. To make a long story short, we've had great success with Gradle. Dependency management is a key component to various systems that we power at LinkedIn that seek to improve developer productivity. And Polyglot Builds, this multilingual build, is an old idea now for us. We have many systems that are running in production composed of multiple languages. And so I want to jump to this example of this Polyglot build because it's going to lead us where Ethan's going to spend some time. I won't read this verbatim, but I think you can get the idea. Projects today that we deploy in our environments are not composed of a single language. They're not composed of a single building block. At LinkedIn, we use Ember.js. We write our front ends with Ember. The backend API server could be Java, it could be Python, it could be Golang, who knows what it is. The point is that to build a single project that's composed of multiple things, we couldn't let people come up with their own idea. It's just very, very messy. And so we thought about using Gradle to solve this problem. And this is just a task dependency tree. It's not going to be a surprise to anybody. It's really not even important to read the nodes. What's important here is that this plugin architecture that Gradle provides us let us focus on our domain and solve just that domain. And so for the remainder of the talk, we're going to focus in on these yellow dots. It's our Python build system. And we're going to show, in addition to what we talked about last year and how we designed it, a real world working example of what we have so far and how we use it. To close, I wanted to just touch on something that we did a month ago. And we went to PyCon and we presented the same idea. And I was kind of nervous going into PyCon because I was like, oh man, these Python developers are going to kill us for presenting a build system that runs on the JVM. But actually the problems that they were talking about this year at PyCon were we're very similar to the problems that Gradle is seeking to solve. And so when we presented this poster at PyCon, we were received very well. Zvezda and Ethan and I and Lauren Carvalho, who's not here, we spent 2 or 3 hours talking with interested parties all over the industry to use this type of technology. And so I just wanted to say in closing that this is an exciting technology that people are ready to eat up. So I'm going to hand you off now to Ethan to give you a hands-on example of what we're talking about in theory here now and last year. So thank you.
Sorry. Thank you, Stephen. So we're going to go through 2 quick examples here. We're going to start a project from scratch, show how Python can build the project, how you would use the plugins, and show how you would interact with it. So I'm going to go to a terminal. I have a demo, pretty basic. I've got a build.gradle. I also can't type, so apologies. Build.gradle, I have a repository set up so that I have my artifacts locally, so I don't have to rely on an external repository, because everyone knows network access at a conference can be a little spotty. So I've already published the plugin to my local Maven repo, so I'm going to just build script and do the normal kata stuff you would do. Dependencies, class path, PyGradle, I really can't type. It's surprising I've made it this far. And we're just going to use the latest version because I know it's good. Repositories. We're just going to do Maven local real quick and Maven central for a dependency. And then I'm just going to apply the Python plugin. Right quit, and run the build. And so what we're going to do here is we're provisioning a virtual environment. We're installing some required tools that PyGradle needs, and you're going to probably need anyways in your environment. We're installing some dependencies for validation, doc generation, flake8, things like that. We're going to go. I'm going to pause it real quick on the build. You can see here, we're telling you how long it takes for a dependency to install. So you know that if it takes a minute for something to go, you'll know where this time is being spent. You might want to think about repackaging that to something that's quicker to install. Let's run. And luckily, we're going to fail. Flake8's going to be mad at me because I don't have a source dist or a test directory, or a source package or a test package. So I'm just going to make them real quick. And then if I run this again, it'll get farther. And you saw here how it skipped a bunch of those installs because they've already been installed. They're already there to be used. And now it failed because it couldn't install the project. That's because we use the Python tooling that exists today. So we have to integrate with it. So what we're calling is Python install the project. So I need to go make a setup py so Python knows how to install this module. I'm going to import setup tools and just do setup tools.setup. I'm going to give it a name. And in proper programming style, name it foo. Version and 123. And then I'm going to tell Python that I want to change where my sources are. So I'm going to use packagedir to be more standard to how you would feel in a Gradle environment. You wouldn't put all your sources in the root, you'd put it in a folder somewhere. So, and in that guy. So, from a working that I was doing before, I was activated in an environment. I'm going to deactivate. When Gradle ran, it created an activate script. So I can just go through here and do source activate. And I'm in there. So I could do pip freeze. And it'll show me all my dependencies. Kind of nifty. So I'm going to go through and delete one of the dependencies that I've installed. I'm going to do pytzy, or PyTZ. It's going to list them all off. I'm going to click yes. It's deleted. If I do it again, it's not there. So I'm just going to run Gradle W again. Run the build. Go through, skip some stuff. It's installing, if I go back up a smidge, you'll see that it reinstalled PyTZ because it was missing. It saw that it was missing and reinstalled it for you. When we install things, we don't let Python do dependency resolution. We do no dependencies, and we let Gradle do all the dependency resolution, so you can use Gradle's really powerful dependency rules to pick which versions you need. My build was successful. We're using a newer version of PyTest, which will actually fail out or warn you if you don't have any tests. So let's write some tests. Let's put some actual code in this thing. I'm going to make a greeting. Let's call it foo. Because I can't type, I'm not going to type the whole thing out. And if you remembered from the keynote yesterday, you have to have a comma after the hello. And so we're just going to return hello, or hello world. I'm going to go into my test directory. I'm going to write test foo.py. I'm going to import foo. I'm going to make a test. And I'm going to assert that it's correct. But I don't trust tests that I haven't seen fail once, so I'm going to make it fail. And since this is an active Python environment, I can just run PyTest here. Test, it fails. So I'm going to leave it like it is and run Gradle build and show you what it looks like when a test fails in Gradle. Flake 8 failed on me. So by default, we have Flake 8 enabled on all of our projects. So we want our builds to fail if you don't pass our style guide. It's a violation of style guide. This has the standard Flake 8 style guide applied to it right now, and it requires that there are 2 blank lines after an import. I planned that just so I didn't forget. And we're going to run the build again. Flake 8's installing projects, dependencies. And if we go up, we'll see that the test failed. We don't have the color, but we see that the test output is there. So I'm going to go fix the test. Run the build again. And we'll pass this successfully. Cool. Well, right now we're not actually making anything useful. So why don't we go and make a distribution you could install? So I'm going to go back to the build.gradle, apply a plugin sdist, run the build again, we built the package, and if I look it up, I should see under build directory, distributions, a tar.gz we could install in another virtual environment, just as is with no extra changes. So you can go between a PyGradle project and a normal Python project seamlessly. So you don't have to deal with one system's not, one system is. You can work with it. And this artifact can also go to PyPy if needed. The Python repository for the open source, kind of like Maven Central. This is all fine and good for normal greenfield projects. Why don't we try a more complicated project? If I can go to the right place. Let's try Flask. Flask is a project, it's basically a very thin web server that serves out files. So let's go try to convert that guy. I have him right here. Basically, I have just the Gradle wrapper and a small test web app written. And that's the only changes that I have. So first thing I'm going to do is I'm just going to copy that build.gradle from my previous example over here. I'm going to switch it so it doesn't make a source dist yet, so we can do some work. It shouldn't change anything, but it'll do less work this way, so it'll be faster. And I'm going to take a look at the setup.py for this guy. So he's got some dependencies listed right here. So what I'm going to do is I'm going to take those dependencies and put them in my build.gradle file, because I want Gradle to understand my dependencies and install them for me. Since we're not using Python to install it, we have to do it. So I'm just going to copy this. And in my dependencies closure, I'm just going to paste it. And when you apply the Python plugin, we provide a Python configuration. And I'm going to convert them to our internal format. So we publish them under the PyPy group, because Python doesn't have a grouping system, and just converting them to versions real quick. Make it look nicer. And I'm just going to run the build. And it's going to fail because Python, it's not set up the way we want it to. We test directors in the wrong spot and something like that. So, but we're going to get the environment set up and running first. So every time you start a new project, you build a new virtual environment. So they're completely isolated from each other, so you don't have to deal with installing in one package and doing it in another, affecting your environment, which is nice, but leads to a little bit longer initialization times. We by default provide HTML docs and Java or JSON docs, so they're going to be generated here, and we'll disable them in the future, so it doesn't take time. All right, Flake 8's going to fail. Flake 8 fails too, because they've got a different style guide. They're probably using different modules, different things like that. So we're just going to turn it off. And you can do it like you normally would with -x. I'm going to forget to keep typing -x Flake 8, so I'm going to disable the task. Okay. So if I rerun this build, should be faster. Okay, PyTest failed because we tell PyTest that we want to run from the test directory, which might not be what you as a company wants to do. Maybe you have a different file structure from us. So you can configure this in your build.gradle. So we can go here, we add a Python extension. And this project uses tests. Before I do that, I'm also going to disable the Java doc, build JSON doc, real quick. If I remember right, that will disable generating documentation. Python, the tests all run, and there was much rejoicing. So, why don't we move this to be more standard the way you would want to be? So Flask right now packages it in a way such that the Flask packages at the root and with everything else. So let's do a quick refactor. Just gonna make a source directory and then move Flask into source Flask. We have to update the setup.py because it's looking for a file in a specific place. And while we're at it, let's also make it distribute a package so that someone could consume it and run a Flask app by including this. So we're going to change this to a source dist. Run this again. I forgot to tell Python that I've changed where its sources live, so let's go do that. Just somewhere in here, I'm going to add a new line. We've built SDIS, we've skipped Flake 8, we're running our tests, everything's good. So if I go look at our build directory, you'll see there's distributions, and alongside of it has the package that we built, the HTML docs, and the Java JSON docs. Also, if we look at the build directory, there's a virtual environment directory, which has our virtual environment we've been working in. So we package it inside of our project so you can have multiple sub-project builds all having their own virtual environment without interacting with each other. All right. So that's a quick little demo I wanted to give about how you could write a Python application from scratch and convert possibly a Python application to using PyGradle. And one of the big things that Python is they are a big community. They love sharing, they love doing things. And we do too. We love using open source projects, and Gradle being a great open source project, we want to give back some. So coming soon to a machine near you in a few weeks, PyGradle is going to come. So if you want to use it in the future, you could be able to. Some details about how we're going to do this. It's going to be on the LinkedIn's GitHub page. It's going to be under Apache 2 so that there's no real licensing problems you're going to deal with. The initial release should be available in a few weeks, and I'll talk a little bit about how we're going to do that in the future. And batteries are kind of included. We've got the big battery, but you have to include some of them yourself. We'll talk about that in a second. So let's say what's in the box. You're going to get the SDIS plugin. You're going to get the PEX plugin. You're going to get tab completion generation. So we've got a script that'll generate tab completion for you. We've got a custom setup tools distribution class that you need to use, or something similar in a PEX project, and I'll go show you how to do that in a Flake project in a minute. And we've got a binary importer. So you saw the build script that I used to start with had a repository defined. That's because Python doesn't, or Gradle doesn't understand PyPy. So what we do is we import the module, convert it to Ivy, and publish an Ivy file alongside the package in Ivy, so that Gradle can compute, decide what it needs to do. You can use dependency resolution, things like that. So in the distribution is this file right here. I'm just going to copy and paste it and go back to my terminal. And I need to tell SetupPy how to do some of this stuff. Or I need to tell Flask how to use the PEX plugin. So up here at the top, I'm just going to add some new lines so I don't mess up the formatting. I have to delete this later. And I need to move some imports because we need some imports to be at the very top for it to run. Delete. Just going to put them on the top. So this is a modified version of the setup tools class that we use. You could package it up. You could do a lot of things with it. You could make it custom to your project specifically. But we're going to give you something to work off of. So the first bit here is how we get information from Python about how to do executables. Sorry, up a little bit. Executables. It adds a entry points command to the sdist, or the setup.py executable. The second bit here is a standard hack for Python to get namespace packages. So you don't have to think about it, you can just use it. This comes from pip issue 3. So it's a fairly early bug that they haven't fixed yet. They've just made it easier to work around. And then this is how we get the name and version information from Gradle. We pass it through an environment variable. And then I'm just going to take this one line out of that setup class and put it there. And assuming that the stars have aligned properly, oh, I need to update the build.gradle. So I apply pex. It'll work. Crossing fingers. There's always a caveat sometime. One of the things we're going to see differently now is we're actually going to build wheels. So pex requires wheels to be built, and they happen basically behind the scenes for you automatically. And it looks like it worked. Yes. So let's let this go. Actually, we don't need to. We've already built the pex file. So we go and build/deployable bin flask. So right now, I'm not activated. If I go look at my Python, it's the system Python. But if I do build deployable, I'm going to call the run command. I changed it. It's going to run the sample that I have called simple. So let's just redo that. So now I've got a application built by Pygradle running as a PEX file, including all of its dependencies that it needs. And if I click on this link, it'll say hello world to me, which is exactly what, let me go back, the simple Python tells it to do. Just returns hello world. So we've gone from a project not using Pygradle at all, building Pygradle, building a PEX file that can be just executable by a user, and just running an web application. And so I want to tell you what the boundaries that you have to include. We're not going to mirror PyPy. That's not something that LinkedIn wants to be the business of. It's something that would be hard and security vulnerabilities and things like that. So we're not going to do that, but we're going to provide you with the tool so that you can import them into a repository that you need. When this becomes open sourced and you look at the source code, it's the same thing that we use for our integration tests. So that's how we're validating it. We're running it as our integration suite. And so here's our plan. There are no dates on things because dates are always going to be wrong. We're going to do an initial release of 0.2.0. We've been using this for a year and a half internally, but the community may have changes they need. And so instead of doing a 1.0 version and having to do a 2.0 quickly after, we're going to leave it as an unstable, allow contributions back, make changes, see what we need, and then we'll do a stable release. And then eventually, when software model becomes a good thing, we'll do a software model release that allows for some better multiple versions of Python to happen at the same time. And the nice logo that the Gradle folk were kind enough to make for us. Any questions? Yeah. Hey.
First of all, you sound aggressive. Actually, I was going to ask, so when you're talking about different Python versions, can you have a package that you designate as like a 2.7 or a 3.0 package and have that filter when you're doing dependency resolution?
So usually what you would do is you would install a source, you would make a source dist, and then let it recompile.
Okay.
Or rebuild, I guess. There's no compiling.
Okay, so you just pass around source disks, but there's no way to really, so you're not checking source disks into any of your repos?
The repos, like when you publish to, let's say, Artifactory, we publish the source dist. We publish PEXs too, but we also publish source disks so that people can include them, because they're really the standard metadata format for all of Python.
Your libraries need to include code that supports multiple versions. It's doable with a 6 package, compatibility package.
Yeah.
So you can use that in your libraries to support that. And your deployable will always be only on one version. So that deployable choice of, say, Python 3 will determine how the library is built. While if you choose Python 2, again, the library will comply accordingly to the 6 different forks.
Yeah, that's my next comment is that without having that designation, the code in itself may fail. If you have the source disk, you can recompile it, it's supposed to fail.
And the last part would be that the standard way forward for Python is going to be to use wheels. Right now, and the wheel will specify the version of Python that it is compatible with. Right now, as a library input, we don't accept wheels right now. We generate wheels behind the scenes to build deployable products, but we don't use them as library dependencies yet. We would love to. There's a few challenges in doing so. We would have to set up a build matrix-like system so that we can build all of the different flavors of wheels that we need to support, but it's certainly on our radar. And it's going to speed up builds, and it is the way forward. So we do plan to support that.
Another question.
All right.
Do you do anything as far as like native compilation? I mean, that part of that may be in the wheels, but in doing some of our compilation, we have issues with like scikit, whatever you have to do, native compilation. What do you guys do about that? You just kind of let Python handle all that? Is there anything special you can do there?
So we use source distributions again, and so being LinkedIn, we have control over our build environment, and so we've had to enhance our build environment to ensure that all of those packages that we need are there. So simple answer, but we use source distributions, and we ensure that our environment looks correct. If we were to think back to that, Polyglot Builds, and how can we build our native code alongside our Python builds? So we have the Python plugin system ready, right? And on that task graph, we have all of the yellow parts solved. An additional part is going to be the native code that we are needing to build our code. We don't have all of the native plugins yet that we need, but it would be trivial to build. I mean, we actually do, but.
So we have multivariant builds, actually.
Yes.
We do have multivariant builds. So what we are really interested in is really limited flavors, Linux and Darwin, maybe 2 versions of Red Hat, maybe 2 versions of Darwin. So we can, in a product specification, say this product needs to build in these flavors. It will actually trigger during the build all 4 builds and produce 4 outputs. They will have suffixes _Linux _x86 64, and that will be deployable on a machine, maybe Red Hat 7, and that will be deployable on those kinds of machines, while the other one will be on Darwin.
And I think what Svetlana is pointing out is with those additional inputs, knowing that you're building on Linux x86, now we have enough information in our build.gradle to declare a dependency on OpenBLAS, which we need to build scikit. And so the information's there, but we haven't standardized with our plugins yet how we're going to solve that with the community. That's one of the biggest problems in Python right now, is that you can't elegantly declare your dependencies on native code.
Yeah. I've seen something called mini Linux. I don't know that.
Yeah, they presented that at PyCon this year too, and that's one branch that's trying to solve the same problem. I think Gradle is a perfectly valid solution to that problem as well.
Will the original version of the Gradle support Node C project? What's the project environment of Python? Meaning like a different project, and then you can enter project depend on each other or depend on other project and include them?
Yep, you can do that. It'll use source distributions to do it, but you can do it.
What's the structure like inside your deliverable tar.bz file? Just curious. That's what I was thinking, but I'm just curious about it.
You can actually,
No.
so you can open tar.bz and
Yeah.
show you. No, he meant probably the
Do
distribution.
you mean the source dist, or do you mean the
Yeah,
PEX?
the source.
Oh, sorry.
So under the hood, we set up by estis.
This is just
So
plain
it's
Python package.
just plain Python package.
Now, if you could open the, can you copy the PEX file into .zip extension and open it in them?
I'm sure I could.
I have set up my Vim to open PEX as a zip.
What?
It'll show you the internal format of the zip. The internal.
Yeah,
Unzip-
you're,
unzip the shell.
somehow you're done to do it, but I don't know. I've set up my event to open this as a zip file, and it shows you structure. It's really a collection. There's a subdirectory called install that has collection of wheels, and wheels are just in their standard format. And yep, there you go.
This is this text format from Twitter.
And once you run this specs file, it will unpick itself. I think the file is available. You ran specs already.
Where is it?
Probably somewhere in .pex or depending how you set it up there, if you want to unpack, it will be. So you can even debug your application later when it's running by visiting that and changing maybe setting the debug points into the unpacked specs.
Any other questions?
Unless somebody else does about the wheels.
Yeah.
Wheels are basically just representing all the binary dependencies, or the binary compilation. Is that how wheels kind of work?
So a wheel is like an egg. It does contain binary code. That's what speeds up compilation. And it has a few metadata format changes that improve it compared to an egg. And so it's a standard Python format. There's text out for it.
You can't have dependencies for the libraries on wheels. Is that what we consider?
So this is a limitation of Pygradle, not Python.
Oh, okay.
So in Python, yes, you can pip install a wheel, and installs very quickly. It's really snappy. In Pygradle, we can't do that yet because we don't have a solution for the multiple platform problem, and that's why we choose to use source distributions. It's easier. It's first version. So although we want to support the wheels, it's on our radar. We haven't done that quite yet.
Basically, in a wheel, Python files are source code. The C extensions are compiled into SO files. .so or .dive.
Anything else? All right. We'll give you guys a few minutes to your day back. Thanks.